I miss you already. I wanted to quick review the very quick half lesson that you got right before we left as a first day of dividing decimals. It's been a week and we just introduced it. So I want you to review with me. Go ahead and open up your interactive notebooks to this page. And then if you are somebody who was not there or you did not glue it in, I want you to pause the video. I sent you decimal squares in your packets. You can cut 2 of them out and put this into your interactive notebook as a model or an example. So go ahead and pause the video and do that if you haven't. All right, what do we model first? And I hope you all said what we are dividing because we have been preaching that and preaching that. So this is what we're dividing, 1 2/10. So I need you to go ahead and model 1 whole. And a flat is 1 whole. It's 10/10 or 1 whole. And then, oops, I'm in my own head here. All right, and then we have 2/10. So we have 1 rod, that's 1/10 or 10/100. And here's 2/10 or 20/100. And this models 1 2/10. Now, the problem is asking us to put it in 4 groups. So we're gonna do 1, 2, 3, 4. And what we are going to do is to evenly divide them. So I'm going to put 1 rod or 1/10 here, another rod or 1/10 here, another rod or 1/10 here. Okay, group 4, and then I'm going to do that again. And I see that I have 4/10 left, so I'm going to give 1 to each group. And so each group has 3 rods, which is the same as 3/10. Therefore, 1 2/10 divided by 4 equals 3/10. Kylie went to the hardware store and bought 6 identical copper pipes. When Kylie lined up the pipes end to end, the line was 1 62/100 meters long. How long was each pipe? Problem. Kylie went to the hardware store and bought 6 identical copper pipes. And when Kylie lined up the pipes end to end, the line was 1 62/100 meters long. And then the question is asking, how long was each pipe? So there's not really anything that would help us in the department of keywords, and we know those are dangerous anyway. So in the final question, the word each is there, so that does tell us a little something. But even using our common sense and going through and looking at this problem, we have 6 pipes and we have length, and we're figuring out how much each pipe's length is. And so what we are doing is we're taking this length and we're giving some to pipe 1 equally, pipe 2, pipe 3, pipe 4, pipe 5. So if I'm giving out, so to speak, this length to each pipe, what motion am I doing? Yeah, I am taking from the length and giving it to the pipes. Therefore, what are we doing? We are dividing. So we are dividing the length, and that means that is what we would write first in our expression. And we are putting it into 6 groups. So what I'm going to do next is model using the decimal squares that you got introduced to on Friday afternoon before you left, and see if that helps you model. Okay, so with Kylie, who went to a hardware store, she bought 6 identical copper pipes. All put together, they were 1 62/100. And as we had discussed, that is what we are dividing into the 6 groups. So the first thing that we do is we model the 1 62/100. So we know that it's 1 hole and 10, 20, 30, 40, 50, 60, 1/62 hundredths. And we need to make 6 groups. So we have pipe 1, pipe 2, pipe 3, pipe 4, pipe 5, and pipe 6. So we're going to take the 1/62 hundredths meters and divide it amongst the 6 pipes. So we have 1/10 or 10 hundredths that I'll give to pipe 1. Another 1/10 or 10 hundredths to pipe 2. 1/10 or 10 hundredths to pipe 3. 1/10 or 10 hundredths to pipe 4. 1/10 to pipe 5. 1/10 to pipe 6. Then I'm going to do that again. So pipe 1, pipe 2, pipe 3, pipe 4, pipe 5, pipe 6. And then I'm going to look what I have left. I have 42 tenths. And I know that 6 times 7 is 42. So I know that I can get 1, 2, 3, 4, 5, 6, 7 hundredths. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 hundredths. 1, 2, 3, 4, 5, 6, 7 hundredths. 1, 2, 3, 4, 5, 6, 7 hundredths. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7 hundredths. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, and 7 hundredths to that pipe, which means that each pipe measured, we have 2 tenths and 7 hundredths. So we have 27 hundredths, or if you counted them each individually, you would have 27 hundredths meters. Next problem, it is 3 people will equally split 63 hundredths acres of land. How much land will each person get? So I notice a few, or a couple at least, of really good words that help us determine that we are dividing. I see the word equally, that makes it pretty safe to use keywords, and I also see the word each. But even not relying on dangerous keywords, we can look at that and know that there are 3 people being given land. So I'm taking land and I'm giving it to person 1, and taking land and giving it to person 2, and taking land and giving it to person 3. So that is how I know I am dividing, because I am physically taking something and giving it out into groups. So the first thing that we write in our division expression or equation is what it is that we are dividing, and we are dividing the acres of land. So that would be our first number. And we are dividing it equally amongst 3 people. And that will tell us how much land each person will get. Okay, so for the case of people splitting 63 hundredths acres, and we are dividing it up among 3 people, so I know that I need person 1, person 2, and person 3. First, I'm going to model. Sorry, I'm picking up my colors here. First, I'm going to model the 6300ths. So we have 10, 20, 30, 40, 50, 60, 1, 2, 3 hundredths. And I am now going to divide that amongst the 3 people. So we have 63 hundredths of an acre, 3 people. I see that I can evenly give each group 1/10 or 10 hundredths. Now I can see I can equally do it again. Then I see that I have 3 hundredths left. So I can give 1 here, 1 here, and 1 here. Meaning that each person will get, I have 2/10 and 1 hundredth. Or if we counted them individually, we would have 21 hundredths of an acre. All right, so I'm going to go ahead and ask that you pause this after we read and talk about it and identify any words that stand out to you that help you determine what it is that we are doing, along with using your common sense, and write an expression, and let's see if you get it correct. So let's read it. Ashley's science class weighed 6 identical balls on a scale. The combined weight of the balls was 6/10 of kilograms. What was the weight of each ball? So go ahead and pause the video and identify keywords and what expression or equation you would write. Okay, so coming back, I'm looking at words, and the one word that stands out to me the most is, sorry, I'm having a hard time with my pen. There it goes, is the word each in that final question. When you see words like combine, you think that you are adding. This is why you absolutely cannot rely on keywords, and you really do focus on that final question and what it's asking. But using common sense and physically picturing what's happening, you have 6 balls on a scale and you've got weight, and we talked about length in our other question. So for this one, we're taking the weight and we're giving it to the 6 individual balls to see how much they weigh. So in this case, we are dividing the weight amongst the 6 balls. So I'm going to write 6/10 first, because that is what we are dividing. That's what we're basically handing out here. And we're putting it into 6 groups. So hopefully many of you got this one correct. All right, now I want you to go ahead and pause the video and use your decimal grids in your interactive notebook in math that we put the clear plastic over. I want you to go ahead and see if you can solve this problem using the grids, and then you can play it back and see if you are correct. Those of you that did not glue it in before you left, or something happened, I included some of those decimal grids in your packet so you can use one of those. It would be great if you could put that maybe in a page protector and use an Expo so you can use it over and over again. But at this time, I want you to pause the video and see if you can get this correct using modeling. So now we're looking at Ashley's science class weighing 6 identical balls, and they all together weighed 6/10 of a kilogram. And they're wanting to know how much each ball weighed. So we have ball 1, ball 2, ball 3, ball 4, ball 5, ball 6. And we need to model what we are dividing. That's the 6/10 of a kilogram. So I need to go ahead and model that. So we have 10 tenths, or sorry, 10 100ths or 1/10, 2 tenths or 20 hundredths, 3 tenths or 30 hundredths, 4 tenths, 5 tenths, 6 tenths, because each one is a rod. All right, and now I can evenly distribute them amongst my 6 groups, and I see that it's made it pretty easy for me. So here's ball 1, ball 2, ball 3, ball 4, ball 5, and ball 6. So each ball is 1/10 of a kilogram, or you can look at it as 10/100ths of a kilogram. And as you learned in class, that has the same exact value. 1/10 has the same value as 10/100ths. Both would be correct.